So let's say your organization has servers, which means you have storage, whether they're on premise or up in the cloud. So we're talking about hard drives. We don't have a budget for this stuff. When we talk about storage, we want to make sure that the storage is plentiful. We want to make sure that the storage is fast. And we also want to make it so that if one of our hard drives breaks, we're not out of luck. We're not a sitting duck for failure. Thankfully, IT has a response for this. It's called RAID, Redundant Array of Independent Disks. Let's talk about that. First of all, this is an extremely complex topic, and we're not going to go deep into details because Kevin won't let me. But what I do want to do is I do want to give you an overview of what some of the most popular configurations are for using multiple disks to give you the best performance, the best capacity, and protection against individual device failovers. So let's walk through these, shall we? First of all, you're going to hear the term RAID followed by a number, usually. RAID 0, RAID 1. It also might be called mirroring or the like. But the bottom line is there are some standards. And what they basically are is a piece of hardware, the disk controller for the server or servers, that is then used to use multiple drives together. So let's start with RAID 1. We take two hard drives, we pair them together. It's called mirroring. Everything that is written to this drive is also written to this drive automatically. So they're essentially duplicates of each other. To the end user, it looks like a single drive. So we're sacrificing, we only get half of the storage of these two drives. But if one of these go bad, this guy keeps on going. So we lose half of the storage. The performance is roughly the same, but we have a failover. The second I want to talk about is RAID 0 or striping. Striping is when you want very fast drives and you also want a lot of storage. So what you do is you take multiple drives and you literally put them together so that the user just sees this one, but it's all three. So you have all of the storage, 3 times the storage of an individual drive, showing as one drive. And whenever you're reading or writing data, you're actually doing it 3 times simultaneously, so it's roughly 3 times as fast. Problem is, one drive goes out, you're toast. There's no failover for a RAID 0. The third RAID I want to talk about is called striping with parody. It's a little more complicated, but you'll get the idea. This is where we, just like RAID 0, we have 3 drives, but we write the data to 2 of them, and we basically write something called parody to the third. And what that does is that creates roughly the same situation. We have a single drive sitting here, but instead of all 3 storage being used, only 2. So we get 2 times the storage here. But what ends up happening is if any of these drives go bad, these 2 can continue to operate. So you end up with twice, 2/3 of the storage, twice the storage of an individual server, which also leads to about twice the performance, but you do have failover. So you kind of get the best of both worlds. The last one I want to talk about is RAID 10, or 1 and 0, or 1-0, which is essentially striping with mirroring. How this is done is actually a combination of mirroring and then striping. So what happens, and this requires a minimum of 4 drives, is these 2 guys are mirrored to each other, these 2 guys are mirrored to each other, and then the result, we're going to stripe. So the nice thing here is that we can lose this drive, we can use this, we can lose these 2 drives and continue to go. If we lose these 2 drives, we're SOL. End result is with this configuration, we get roughly 50% of the total storage. We get roughly twice the performance. The benefit on a RAID 10 versus a RAID 5 is rebuilding. Let's talk about that for a quick second. The nice thing about most of the RAID configurations, outside of just the striping option, is that if the drive fails, the server will tell us somehow. That's why you pay attention to the blinking lights on the front panel of the server, or monitoring software. Hello? And you can actually replace, often with newer servers, you can literally unplug the bad drive, plug in its replacement, and the server will rebuild automatically. So no downtime, no lost time, not lost productivity, but depending upon which RAID you're using, some of the rebuilds are faster than others, and some of the rebuilds will slow the server down temporarily. But the bottom line is, using these RAID configurations properly, you can actually make sure that you're protected against downtime, you're taking advantage of the storage as most effectively and efficiently as possible, and you can actually make sure that individual volumes that the end users see have the amount of space needed. Now, I want to be clear, these are not backups. A RAID configuration is simply to improve the operational effectiveness and reliability of the network. They are not backups in any way, shape, or form. And for the most part, you just need a decent hard drive controller with the server and then the hard drives. Now, I've simplified this tremendously, and it's critical from a CEO standpoint to just recognize why, when someone says it's a RAID or whatever, what it means, and if you're the internal IT person, to understand some of the nuances between. Now, there's literally about half a dozen to a dozen other versions of RAID, other RAID configurations, but these are the popular ones. So how do you make sure you're optimizing storage for your server? Tell me about it in the comments below.